Okay, analyzing graphs to find acceleration. We did this in the last graph, but I wanted to review it just a little bit. Refer to this figure to find the acceleration of the moving object in each of the following times. During the first 5 seconds of travel, that would be here. So remember, the acceleration is a slope of a velocity time graph. So if I look at these 2 points, my last point is 5:30. And my initial point was 0, 0. So if I find the slope, change in y over change in x, it's going to be 30 minus 0 over 5 minus 0 equals 6 meters per second squared. 30 minus 5. Excuse me, 30 divided by 5. Between 5 seconds and 10 seconds, and that would be here. If the velocity is staying constant, what's your acceleration? What is the slope of a horizontal line? We don't have to find 2 points and subtract them here. You know what the slope of a horizontal line is. Acceleration is 0 during that time interval. It would also be 0 during this time interval. Anywhere, if you have a horizontal line, the slope is 0 for a velocity time graph. That means the velocity is not changing. That means there's no acceleration. And between 20 seconds and 25 seconds, that's this time interval here, we have our initial point of 2020 and our final point of 25:0. So if I want to find slope, change in y over change in x, so that's going to be 20 minus 0 divided by 20 minus 25. 20 minus 0 is 20. 20 minus 25 is negative 5. 5 goes into 24 times, so the acceleration is negative 4 meters per second squared. So a positive slope indicates a positive acceleration, and a negative slope indicates a negative acceleration. A dragster starting from rest, so we have an initial velocity, accelerates at 49 meters per second squared, so we know our acceleration. How fast is it going when it has traveled? We're looking for final velocity. When it has traveled 325 meters. So we need an equation with VI, A, VF, and D, displacement. So look at that last one. There's VF, VI, acceleration, and distance. So the equation we're using is VF squared equals VI squared plus 2AD. And we're looking for VF, so here's the quantity we're looking for. So I know that VF is going to be the square root of VI squared plus 2AD equals the square root of, and VI was 0. Two times 49 times 325. Okay, pull out my handy dandy calculator. 2 times 49 times 325. 31850. And when I hit the square root button, I get 178.5 meters per second. Okay, let's try another one. A car moves at 12 meters per second and coasts up a hill with a uniform acceleration of negative 1.6 meters per second squared. So if a car is coasting up a hill, it's going to be slowing down. So gravity is pulling it back down the hill. The acceleration will be opposite the direction of the velocity. What's the displacement after 6 seconds? And what's the displacement after 9 seconds? Okay, a car moves at 12 meters per second. That's our initial velocity. So VI equals 12 meters per second, and coasts up a hill with a uniform acceleration of negative 1.6 meters per second squared. Now it's negative, if the car is coasting up a hill, it's going to be slowing down. So the acceleration and the initial velocity are in opposite directions. And we're looking for the displacement at time is 6 seconds, and then at time is 9 seconds. So if we look at our equations, we have one we haven't used before. And that's our final position equals our initial position plus our initial velocity times time plus 1/2 AET squared. We're looking for that final position. We can say the displacement at the beginning of 6 seconds is 0. So this quantity is going to go away. We have our initial velocity, we have time, acceleration, and we have time. And luckily, what we're looking for is sitting out here. We don't have to rearrange the equation. So let's start plugging stuff in. The final position equals 0 plus 12 times 6 plus 1/2 negative 1.6 times 6 squared. So I pull out my calculator, 12 times 6 is 72. 0.5 times 1.6, now that's negative, times 6 squared is 36, is negative 28.8. And when I add 72 to negative 28.8, I get 43.2. So what that tells me is that the car is still moving up the hill. They're further up than they were. You know, if they're going up this hill, and this was, they started down here at the 0 position, then they have moved some distance positive up the hill. Let's see what happens after 9 seconds though. Notice we have a time squared here. It makes this term get bigger and bigger faster than this term, and this is negative. So let's see where they are on this hill at 9 seconds. So we have the same equation. I'm not going to rewrite it. It's because it's right here. I'm going to start plugging stuff in. df equals, initial position is still 0. Initial velocity is still 12. Time now is 9 seconds. 1/2. Acceleration is still negative 1.6, and time is 9 seconds, and the time is squared. So 12 times 9 is 108. And I'm going to go ahead and put a minus sign here because I know this is going to be negative. So 0.5 times 1.6 times 81 equals 64.8. And 108 minus 64.8 is 43.2. Now that's weird. So let's think about how can it be at 43.2 after 9 seconds and at 43.2 after 6 seconds when it has remained moving the whole time. Well, what happened was, for the first part, A, the car had moved from here to here, and then the car continued to move up the hill a little bit, and then it turned around and started moving back down the hill. And so it is back at that 43.2 position after 9 seconds. So it has, at beyond 6 seconds, it only went up just a tiny bit more for another 1.5 seconds, and then it turned around and came back down, and so it was at the same position. How far does a plane fly in 15 seconds while the velocity is changing from 145 to 75 at a uniform rate of acceleration? So we're looking for a distance. We know the time is 15. We know the initial velocity is 145. We know the final velocity is 75. We don't have an equation that just has d and t and vi and vf. We have one that has vi and vf and d and a and acceleration. We're going to have to find acceleration. Well, we can do that. Acceleration is a change in velocity over time. Vf, 75, minus vi, 145, over time is 15 seconds. Oops, that's not a parenthesis. Hold on a second. My 1 was squiggly and it made me think it was a parenthesis. So let me go back and write that a little bit more neatly. 145. So 75 minus 145 is negative 70 over 15 divided by 15 is negative 4.7. Now I can go back and use this equation to find d. Or I could use this equation because I know time, I know acceleration, I know time, initial velocity, I know the initial position is 0, and that's what I'm looking for. Okay, let's try that one instead. Simply because if I use this one, I'm going to have to do some rearranging, some algebra to get d by itself, whereas with this one, everything is, the d is out here by itself already. So df equals di plus vit plus 1 half a t squared equals 0 plus 145 times 15 plus 1 half times negative 4.7 times 15 squared. 145 times 15 equals 2175. I know this is going to be negative because my acceleration is, so 15 squared times 4.7 times 0.5. I get a negative 528.8. So 2175 minus 528.8 is 1646.2 meters. And we're all done. So these problems aren't hard. You do have to find the equation you want to use. Sometimes more than one will work. Sometimes you have to use 2 equations in the same problem like we did here. Sometimes you don't have everything you need for any of the equations, but you can find something else that will fill in the blanks for you, like we had to find acceleration here. So good luck with these problems. Ask for help if you need it. Thanks.